Okay, so sometimes with trig identities, the directions could say simplify. All right, so right now, again, we really only know a few, so we're not really getting there yet, but we will slowly. So when I look at this and I see, anytime you see sine, sine, cosine, cosine, sine, cosine, cosine, sine, you know it's a trig identity. So you look at your little trig identity sheet and you're like, oh, this is sine of an angle like alpha, cosine beta, and then this is cosine alpha, and then sine beta. So then you look at your trig identity sheet and you're like, oh, okay, that's the sine of alpha plus beta trig identity. So if the directions say simplify, you're just going to go backwards. So you know the output to that trig identity, you're going to go back and kind of use the input to simplify. So my alpha is 7 and my beta is 2. And so to simplify, really, you just add 9 degrees. That's it. That's all there is to do it. I don't want an exact answer. That's all I want. And so you're done. If I wanted an exact answer as far as a ratio goes, you'd have to use a calculator on degrees. All right, the next one. I want you to simplify this. All right, and so again, when you see sine, cosine, minus cosine, oh shoot, I probably wrote something wrong there. That should be a sine over here. So this should be sine. Sorry about that. That should say sine. Okay, so when you see something like that, again, you should be thinking trig identity. Now, before you decide which trig identity, you need to look here. These angles match, but those don't. And so you can't have alpha be, negative t, that's fine, but beta be a positive 2t and a negative 2t at the same time. That is a problem. So what I'm going to do is anytime you have negative angles in here, you want to deal with even and odd functions. So sine is odd. Remember, the effects stick with you. So that's that. Cosine's an even function, so it wouldn't matter if it's negative. This is an even function, so I basically can just drop the negative in my angle. It's not going to hurt anything. And then sine is an odd function, so again, that negative sticks with you. Now, when I pull that negative out, I get a double negative there, so that's actually a positive. All right, so now when I look at this, it still doesn't match the trig identity because none of our trig identities have a negative up front. So we need to really factor that negative out. And so I get sine of t, cosine of 2t. Now, this is positive. So when I pull a negative out, there's actually a negative left there. All right, so you can kind of see, my negative would distribute and then my negative would distribute. So I factored correctly. So now when I look at this, I'm like, okay, so here's my alpha, here's my beta, here's my alpha, here's my beta. And again, anytime you see sine, sine, cosine, cosine, things like that, you look for the trig identity that fits it. And so in this case, I have this part right here is sine of alpha minus beta. That's the trig identity it fits because it goes sine, cosine with a minus and then cosine, sine. And so that's the trig identity I'm going to use. So I have a negative up front, and I have sine, and then it's going to be alpha minus beta. Well, my alpha is t, minus my beta is 2t. And that negative just stays up front, and negative t. All right, so again, the directions are simplified, which in algebra means, get it as the best answer you can. Again, negative sticks with you because sine is an odd function. So if this negative comes out, you'll get a double negative. So that means I just end up with sine of t. And again, that's the best answer you can get. And so that's all you need to do.